In the analytical way of determining the velocity and acceleration of the piston, let us discuss the second problem. So this is the problem statement. If the crank and the connecting rod are 300 mm and 1 meter long respectively, and the crank rotates at a constant speed of 200 rpm, determine the crank angle at which the maximum velocity occurs. Okay. So these are the main data given in the problem. Length of the crank small r, that is 300 mm, which is 0.3 meter. Length of the connecting rod small l, that is 1 meter. Engine speed capital N is 200 rpm. It is asked to find out the crank angle theta at which maximum velocity of piston occurs. Okay. We know the velocity formula for the piston. Vp is omega r sin theta plus sin 2 theta by 2n. And the condition for the maximum velocity of piston with respect to the crank angle theta is dvp divided by d theta, that is the differential form of velocity with respect to the crank angle as 0. Okay. To use this condition, first we have to differentiate the velocity of piston expression with respect to theta. Okay. So here omega r is a constant value, so that will be in the differential form as it is, and the differential form for the term sin theta as cos theta plus the constant time 1 by 2n into the differential form of sin 2 theta as 2 cos 2 theta. Okay. So in the second term we can cancel out the 2 in the upper and lower terms. In the simplified form, it will be omega r into cos theta plus cos 2 theta by n, which should be equal to 0 for the maximum velocity condition. If the multiplication of two terms is 0, then either the first term should be equal to 0 or the second term should be equal to 0. Okay. So here omega r is a constant value because omega is angular velocity that will be calculated by the formula 2 pi n by 60. For a particular speed condition, omega will be a constant value, as well as r, crank length, it is a constant value. So the product of omega and r will give a constant value, so that value cannot be equal to 0. Okay. So the only possibility will be the second term, cos theta plus cos 2 theta by n is equal to 0. So by taking LCM, we can write like this: n cos theta plus cos 2 theta whole divided by n is equal to 0. So we can take this n in the denominator to the right hand side. So n multiplied by 0 will be equal to 0. So simply the expression will be n cos theta plus cos 2 theta is equal to 0. So the n can be calculated as L by R. So 1 by 0.3 for the data given in the problem, the n value is 3.33. So to make the above equation, that is n cos theta plus cos 2 theta equal to 0 as a quadratic equation to easily solve, we can use this trigonometric relationship. Cos 2 theta is equal to 2 cos square theta minus 1. So by substituting the n value and cos 2 theta expression, we can have the expression like this. By rearranging the terms, we can get a quadratic equation 2 cos square theta plus 3.33 cos theta minus 1 equal to 0. By solving this quadratic equation, we can get the value of cos theta as 0.26. So theta value as cos inverse of 0.26, that is 75 degree. So this is the answer for the considered problem. That is, for a given condition, the maximum velocity of piston will occur at the crank position of 75 degree.